So hi, I'm Adam. I will be talking about blockchain, how to blockchain, and okay. So maybe a question: how many of you know any programming language? Like I recommend. Okay, cool. Who is doing software development? Blockchain software development? Okay. Who is doing cryptography? Okay. Pretty cool. So we will see today. First is what is needed to have a working blockchain. So blockchain is just a piece of software, like your Discord or Slack or whatever you're running, but it's talking to other machines in the network. Second thing will be why to build your own blockchain, because you have Ethereum, BTC, what is creating another one. And then there are two ways of creating new software, the hard way and the easy way. And then I will show you the easy way and a working example done in Rust with a front end which looks like sort of it is done for that custom blockchain done in the React. And then we'll extend that with something that may look like DNS, which is a decentralized DNS. And then there will be Q&A session. So to have working blockchain, you need a node, which is a piece of software that is running and communicating with other machines on the network. Then you need a pretty good networking stack, first to handle the load, and then to secure connections between the nodes, because evil third party will try to hack you, for sure. Then you need a storage, but not a database, because blockchains usually support reorganization, so you have to have version storage that is able to jump back, and it doesn't require jumping back only when there is reorganization, because sometimes people will ask you, hey, what's the contract state of this contract, but at block height now minus 1,000, and you have to handle that case, which is first preserving that contract state and then being able to access it pretty quickly, for example, for Web3 application integration. And of course, you have to provide consensus, so the nodes on the network will be able to agree on the transactions that are in blocks, and then produce subsequent blocks continuously without crashing. And of course, those transactions have to operate on something, and that something is usually a ledger or any other data structure that preserves information on like who owns what, or what can be done with the assets that you own. So, a lot. And then, if that stack is required, so why would you bother to implement it? So first thing may be that you need like a private deployment. Actually in Poland, there are few companies that are running private blockchain based on Hyperledger Fabric and other solutions. And sometimes the existing software like Ethereum nodes and EVM will not fit your case. So for example, there are overhead of running on EVM, which is not efficient at all. It's meant to be very secure and reliable, and for you to be able to get the same result every time. But if you want a lot of transactions per second, then this may be a bottleneck. And in the end, your use case may be like totally different, that nobody done before. And to do like proof of concept for investor, you just need to do it somehow. So of course there is a hard way. So first you do R&D for a year or two, then implementation another year or two, then auditing, testing, bootstrapping, then testnet, which takes like a few years. And then you hope that somebody will adopt that, use that, and you will get return on your investment. Not a good idea. So there is another way, which is just get software that is on the market right now, like Ethereum node or BTC, and create Bitcoin Cash, Bitcoin SV, whatever. It may work if you want to clone those coins, but usually it doesn't work, as I mentioned before, because those are pieces of software that are designed for a specific purpose, which is
running decentralized ledger for like token transfers, or special case of smart contracts. You can just pick components from, I don't know, from Ethereum, you get networking stack, which is pretty good. Then UTXO model from BTC, and from Zcash, like privacy, and stick those together. But it also doesn't work because each of those are written usually in different languages, and good luck piecing together like Java, C, and Rust, whatever is used there. And there is the last option, which is using, because now, since blockchain is maturing, we have frameworks. Like for web applications, you have frameworks. You do not create your own HTTP server. You just pick one off the shelf, and then you are using it to do your stuff. For example, render web page of your e-commerce. So currently, like there are two popular like SDKs or frameworks are Cosmos SDK, which is implemented in Golang, and then there is second one, which is Substrate. It's from Parity. It's implemented in Rust. There is a difference between them. So Golang implementation, of course, it uses Go, but Cosmos is designed in a way that you only plug your custom logic, which handles ledger transitions, which is the data structure that keep information of who owns what and who can do what with the assets. With Substrate, it's kind of similar idea, but they have a lot of modules that you can plug. So for example, if you don't like their accounting model, which comes for free, you can write your own palette, it's like fancy name, and plug your own account model. You can do the same with consensus. You can do the same pretty much with almost every module. The catch is that some modules are on Apache 2 and some are on GPL, which then you have to publish your code. And this is like how Substrate architecture look like. So you remember from that first slide that we need networking, we need consensus, we need storage to have a blockchain node, and ledger, which we have to implement ourselves. But in addition to those, you're also getting RPC and telemetry, which is WebSocket interface or RPC HTTP-based interface that you can extend. And Substrate provides you a lot of methods that you can call out of the box. Plus, since it's Parity and they are doing Polkadot using exactly this framework, you get pretty nice JavaScript library that you can use to integrate with whatever you create with Substrate. Okay, so famous quote, and then show me the code. So actually, those things that you saw come from for free. So this is like simple Substrate extension. This is written in Rust, which is like preferred programming language. There is a lot of like comments, declaration, but what is important is this piece, because here you can implement your custom actions. So for example, if you want your user to be able to send a transaction that, for example, will do something, and that something will store a number on chain, then you do it like this, which is first you ensure that it's signed by the user, that later you get a storage of something, and then you put into that storage that number. And that's pretty much all it takes. Then you return, okay, so it's fine, I stored the number, don't crash, transaction is accepted. And in addition, you can emit some events. So for example, from Ethereum, you may be remembering that they have event log that is produced. So this is the same concept, but here you have custom events. So you can emit whatever you want. And you can see that this something that's supposed to store your number is just a type defined here, which is storage value that accepts a number. Okay, pretty simple so far. And then there is another method, which is just crash. So if user sends a transaction that is calling this method, then it's like it will fail. Okay. So this is the base logic. Of course, I have it compiled before. So first, I'm starting a node in dev mode, and as you can see, it's doing all the fancy thing, it's initializing, and then it is using proof of authority protocol for consensus, and it's producing blocks and consuming it itself. So this is very nice for prototyping because you don't need any like fancy deployment. You have one binary that you can execute, and then it will just produce blocks. If you send a transaction, it will be included in one of those blocks. So now let's do the front-end part. Okay. And as you can see, it's also fancy front-end. It comes preloaded with accounts with some unknown token that you can use for testing, for sending transaction. You have accounts that you can switch, which is Alice, Bob, and Alice has actually 2 accounts. Bob, same story. So this is what comes for free with Substrate, this accounting model and the transferring of the tokens. So for example, let's transfer some tokens to Bob and maybe 420. Okay, submit transaction, and you can see here that balance will change. And it's changed right now. The transaction is ready, it's in the block, and there are events emitted with that transaction that Bob got our funds. So this is, as I said, standard. But down here, you see this fancy Web3 application that allows me to send a number and do store something. And this store something will create a transaction and call the method that you saw in that Rust code. So right now it's in the block, and it created an event, something stored, that was sent by this address, and of course this address is me, which is Alice. And Alice stored 42 in that contract, and then it's on the blockchain, it's on every node that is running in the network, and it just has 42. A bit useless, but like nice example what's possible with, I know, 20 lines of code. And then if you want to see how it's template module, okay, cause error. So this was calling the transaction via fancy interface. And other than that, you can call transactions directly by choosing their type and then just sending them. And as you probably remember, this should crash. Template module cause error. Okay, it didn't crash. Yeah, maybe. So template module, okay, cause an error, okay, and signed in the block. Strings is successful. So ensure signed, yes. Read storage, get none. Okay. It will crash only if the storage is empty. Increment the value, storage with, okay. So we can crash it like that. Cause an error, signed. Yeah, it crashed now. So if it's empty, then it's crashing. But despite that it's crashing, it's charging me a fee. So if I will try to spam the network with incorrect transactions that are signed by me, then I will get penalized for it. And that's pretty much the example. So if you have any questions, the code, how it's working, what's doing behind the scene, then this is good moment. Any questions? Nobody cares? Okay. So nobody cares. So moving forward. Okay, so what we get for like free, it's not free, but it comes with a framework, is accounting model, ability to transfer coins, and events. As you saw, there were notifications if transaction was successful or transaction failed, and who pays what, and who issued what transactions. And we have UI, which is not terrible, which is nice. And now this is something more interesting, which is using the same mechanism, but not to store like a single number in entire blockchain, but store nicknames. So for example, you can imagine that if you buy a domain like 42.com, it's assigned to you as you are the owner. And of course, there is this ENS, which is running on Ethereum. But let's say you would like to do similar stuff with Substrate. So for sure, it will be very complicated, and it will not fit in this site, or maybe not. So this is full ENS implementations in 400 lines of code, but like 200 of them are just comments and data structure to store whatever you want to. Sorry, those are also tests. So to do ENS, what you need is a storage. And as you remember from previous example, storage is just a type that is annotated with a specific macro. And then it should be somewhere here. Yeah, this one. Okay, so what you need to store mapping between a name and somebody. So that somebody will be probably represented by account ID, which is address, the owner. And then you need something to store the actual domain or nickname. So that can be done with bounded vector. Okay, so this is declaration of storage. Then you declare a transaction that can be issued, and that will just set a name. You get the sender for free because sender have to sign a transaction. So this is extracting sender for you. And then the name of a domain that you want to reserve or buy. And of course, you have to check if it's not too long, too short, it will fit into the storage, and then you do insert. Okay. Then you have another another transaction to clear the name. So for example, you no longer need the domain, and then you deposited some coins with it. And then if you want to get the coins back, free the domain so somebody else can buy it, you just clear the name. Okay. And it's already compiled into this version. So as you can see, this is the fancy name extrinsic, which is substrate name for transactions. And right now it's called nix and then set name. So as Alice, I would like to reserve a domain, which is 42.42.42.com. And I want to sign it. And it's ready, and it will charge me. Yeah, it did. And then you have another logs, which is extrinsic successful. And down here, you can see that I reserved a name, and I paid for it 100 tokens or whatever. And now I can, of course, query that stuff, which is query nix and then name of. And I will just get this Alice. And you can see this is my domain, which is 42 encoded in UTF as bytes. And I have this, like the additional info that to reserve this domain, I paid 100 whatever. And again, I can do clear name. And if I do this, then it will be, the storage will be wiped, and I will get back 100 coins, but I will also pay the fee for calling the transaction. Okay, so this was the extension, and yeah, all those you saw, and that's it. Any questions, comments? That doesn't make sense. It's fun, it's useless. Okay. Yes. Runtime? Okay. So runtime, it depends what you're using, because runtime is just Rust code that you are running. By default, it's running in WASP. So you can, if you are sticking to WASP, then it will be probably single-threaded. And then if you remove WASP, which is possible, then it's whatever you want. And then it's your business to ensure that concurrency will not result in conflicts on different nodes. Pretty much Polka. Okay. Pretty much Polka.performance. I don't know. Out of the top of my head, I don't know.
We just ended, so.
Anyone more questions? Okay, great applause. Thank you.
Okay. So if anybody want to read more about blockchain, ZK Snark for formal methods, then this is my LinkedIn, and I'm doing some publication there. Thank you.